Welcome to Faulhaber Drive Time. In today's video, I will show you how to select the winding of your stepper motor based on your application and your power supply. During this video, I will do a practical example using the MCST3601 driver and an AM1524 stepper motor. For more information about the connection of this product, you can look at our other video on our YouTube channel. So, our stepper motors have different winding types, which means that different types of coils are used for the same motor diameter. If we take a look at the datasheet of the AM1524, we see that this motor has actually 4 different winding types. In the motor that we will use today, we have the winding type 0250, which corresponds to a nominal current of the motor of 250 milliamps. Another important part of the datasheet of the stepper motor are the torque and speed curves. On this curve, you see on the vertical axis the torque, and on the horizontal axis, the speed. All the points that are below the curve can be reached by the stepper motor. If you try to reach a point that is above the curve, for example, if you have a torque that is too high for a given speed, the stepper motor will lose step, lose synchronism, and eventually stall. We see that there are actually 3 curves, and on the top right corner, we see that these curves correspond to different ratio between your supply voltage and your nominal voltage. For example, if you want to work in this first area, you will need to have a ratio between your supply voltage and your nominal voltage of 2.5. If you want to work at higher speed and have higher torque, for example in this second area, you will need to have a ratio of 5 between the supply and the nominal voltage. We'll now do a numerical example so that you can understand this concept better. If we take the example of the AM1524 and have a look at the 0150 winding, we see that this winding type has a 6 volt nominal voltage. This means that if you are using a 6 volt power supply, you will have a ratio of 1, and you will be able to work in this area. Now, if you decide to use again a 6 volt supply voltage, but take the 0450 winding type, which has a ratio of 2 volt, you will have another ratio, this time a ratio of 3. This means that you will be able to work in a larger area like this. Now, if you take the 0450 winding type and use a 10 volt power supply, you will have a ratio of 5 and will be able to work with the entire working area of the motor and reach the maximum speed and torque. We'll now do a practical example with the stepper motor AM1524 with a winding 0250. We see in the datasheet that this motor has a nominal voltage of 3.5 volts, and we will now use a supply voltage of 9 volts. This means that we have a ratio of around 2.5 between the two. What I will do is that I will give the command to the motor to reach a speed of 12,000 RPM, and we will see what will happen. So I will take the motor in my hand so that there is no resonance effect between the motor and the table. As we've seen, the stepper motor stalled and stopped abruptly and had a high pitching noise. This is because the motor was unable to reach the target command of the 12,000 RPM. Now we'll proceed the same, but with a higher supply voltage. So now I've changed the voltage supply to 12 volts, and again I will give the command to the stepper motor to reach 12,000 RPM. So we see that the stepper motor this time was able to reach the provided speed, and it had a nice acceleration and deceleration curve and no abrupt stop. This means that by increasing the ratio between the supply voltage and the nominal voltage, we were able to reach a higher speed with the stepper motor. So in this video, we've seen with the numerical and practical example how the ratio between the supply voltage and the nominal voltage can have an effect on the working areas of the stepper motor. If you want to know how you should select your winding and the ratio between your supply voltage and nominal voltage, you should have a look at the datasheet of the motor and look at the torque speed curve to find all the information you need. In the next video, we'll discuss about micro-stepping with stepper motor and how it can influence the behavior of the motor. If you have any questions, please feel free to leave a comment under the video or contact your local sales team. Thank you and have a nice day.